this lesson, we're going to take a look at double displacement reactions, which are when we have one element from one compound taking the place of another element in another compound, or partners switching. So general form is the compound AB reacts with the compound CD to produce the compounds AD and CB. So here it's important that whatever comes first again. And so A is going to pair with D, and then C is going to pair with B. So C was written first here, it's written first here as well. A was also written first, and B and D are written second. So we're going to continue to pair those like that. Visual representation right there. So once again, so the circle replaces with the other circle, squares, switch partners. Okay, so examples, writing balanced equations with these reactions. So I have sodium oxide and lithium chloride. So those are going to switch partners. So sodium is going to end up with chloride, and lithium is going to end up with oxide. So for word equations, sodium oxide plus lithium chloride becomes sodium chloride and lithium oxide. And for our skeleton equation, so sodium is a 1 plus, oxygen is a 2 minus. So that's going to give me Na2O. And lithium and chloride, lithium's a 1 plus, chlorine is a 1 minus, so 1-to-1 ratio there. So lithium chloride, and those combine to produce sodium chloride. So sodium's a 1 plus, chlorine's a 1 minus, so 1-to-1 ratio there. And then lithium oxide, lithium's a 1 plus, oxygen's a 2 minus. So Li2O for lithium oxide. And then to balance, so I have sodium, oxygen, lithium, and chlorine. I'm going to write the same order on the other side so I can quickly look across to compare each element. So 2 atoms, 1, 1, and 1, and then here 1 sodium, 1 oxygen, 2 lithium, and 1 chlorine. So our sodiums are unbalanced and our lithiums are unbalanced. So lithium, sodium, that now gives me 2 lithium and also 2 chlorine. And on this side, 2 sodium and 2 chlorine. So everything is now balanced. Calcium fluoride and zinc carbonate. So calcium is a 2 plus, chlorine's a 1 minus, zinc 2 plus, carbonate CO3 and 2 minus. So calcium fluoride is going to be CaF2, and zinc carbonate, so we have 2 and 2, so it's a 1-to-1 ratio. And then calcium is going to pair with carbonate. So I have a 2 plus, 2 minus, so 1-to-1 ratio. And then zinc will pair with fluorine, so a 2 plus and a 1 minus. So that's going to give me ZnF2. And as I look here, I have 1 calcium, 2 fluorine, 2 fluorine, 1 zinc, 1 zinc, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen. So this is already balanced. Specific case of double displacement reactions are neutralization reactions. So this is where specifically our reactants are an acid and a base, so something with a pH less than 7 for the acid, greater than 7 for the base. And when those two combine, they make a salt and water. So acids are often something paired with a hydrogen, and bases are often paired with a hydroxide. So the hydrogen and hydroxide combine to make H2O, and then the pairs with the hydroxide and the hydrogen then combine to create the salt. So similar to before, this was written first in this equation. So when it comes over here, it's still written first. And the A was written second, and that is still written second. So we're doing the same with that for our double displacement reactions. And then HOH, in terms of the pairing, it's often helpful to see water like this when we're balancing equations to see the two different partners that came together. But when we write the full chemical balanced equation, we're going to use H2O to represent water. Okay, phosphoric acid and potassium hydroxide reacting. So potassium hydroxide, that one's easy. We've been doing those types of chemical formula already with hydroxide, which is a polyatomic. So potassium, group 1, it's a 1 plus. From the polyatomic table, hydroxide is a 1 minus. So that's a 1-to-1 ratio. For acids, when we have the polyatomic that ended in 8, and that's dropped off, and we have auric acid or ic acid on the end of it, then what that means is we had a hydrogen that's paired with the polyatomic ion. So up till here, what we would add back is the 8. So this is for phosphate, the acid that's created when hydrogen pairs with phosphate. So here, as I do my crisscross, H3PO4 is phosphoric acid. So that pairs with potassium hydroxide. So I'm going to have the hydrogen and hydroxide come together to make water, and potassium and phosphate come together. So potassium is a 1, phosphate is a 3, so that's going to give me K3PO4 and water. Now, when we balance these, we can look at pairs instead of individual atoms, and then when we do that, it can be helpful to see water as the pairs from hydrogen and hydroxide. So I can see I have 3 hydrogens here and 1 hydroxide, but I need them in a 1-to-1 ratio, so I'm going to need more hydroxides. I have 1 potassium here, 1 phosphate. I have 1 phosphate but 3 potassium. So I can balance my 3 potassium out here. So 3 potassium to go with my 1 phosphate. And I now have 3 hydroxides to go with my 3 hydrogens, which would be 3 waters. So once again, it's often helpful to see water as the pairing of hydrogen and hydroxide when you're doing the balancing here. And last example, so nitric acid, so that is the pairing of hydrogen with nitrate. So hydrogen is a 1 plus, nitrate is NO3 1 minus, so 1-to-1 ratio there. And sodium hydroxide, sodium group 1 1 plus, hydroxide from our polyatomics OH minus, so 1-to-1 ratio again. And because everything's in 1-to-1 ratios, so our salt, sodium nitrate, 1-to-1, and then H2O, or our HOH, also 1-to-1 ratio there. So that means we're going to be all balanced here. So I have a nitrate, a sodium, sodium, and then H2O for water, or my HOH pair.